So what this bytecode simply means is your .jar files, which I believe you must come across. The .jar package, which you are able to include in your class part when you're writing your Java codes. You include it as a library. A popular example of what so Spring Boot has made us to take for granted a couple of things, such as library management, in the sense that when we plug in our pom.xml file and include the libraries we need there in that file, Maven just checks the version that complies with whatever code you're running and just does the dirty work for you. But without Spring, without such framework, you are manually going to have to find the source code or the bytecode, which is the .jar file, and it has to be compatible with whatever version of Java you're writing, whatever code you're writing. It has to be compatible with it, and then you plug it in. So essentially, what I'm trying to say is Java Virtual Machine helps in the conversion of our Java codes into a .class file, which essentially makes up that thing you call whether it's whatever .jar file, which you can distribute around a non-operating system and use it wherever you wish to. So the second point essentially is the usage of that file anywhere you wish. Write once and run everywhere. It's able to run in any environment you wish to run it, operating system, regardless of whichever it is. So it does the it has different components. The Java version machine has different components within it, which is the class loader, the bytecode verifier, execution engine, runtime data areas, security. So I wouldn't want to. I'll share this later on. I wouldn't want to start explaining each of these points just because of time. And then we have the support for JVM languages, and then memory management. So this memory management essentially is the essence of this session today. So there's the second half of it, not just this one. I highlighted it. That the Java virtual machine provides automatic garbage collection, which handles memory deallocation by identifying and reclaiming memory occupied by objects no longer in use, simplifying memory management. So this is one of our concerns in this session. Also, if you go back, this is also concerning memory management. Memory areas used by JVM for various purposes, including the heap for object storage, method areas for class data, and stack. So this point regarding memory is what we're just going to cover in this session tonight. So, so I'm jumping over to memory management by JVMs. The JVM memory manages memory by organizing it into several runtime data areas, each serving a specific purpose during program execution. The two main ones are the heap and the stack. But of course, there are other memory management components which the JVM has, which includes the meta space, which is responsible for managing the class information, as well as the PC register, which is responsible for managing threads within a Java program. And they are critical to a program's operation. Automatic memory reclamation is primarily handled by garbage collector, which operates within the heap. So these are points we're just going to break down within the few minutes. So if there's any questions so far and you're following, please just let me know. Are we following? And is there any question? So I'm not just talking to myself. Okay, 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 very well. So, so we're just going to break down each of these points. So the stack and the heap, like we mentioned, the stack and the heap, and what goes on within the stack and the heap. You've heard about stack overflow errors. You've heard about garbage collectors, and how exactly did they even work? What does the heap do? So if you take the stack is a thread-specific memory area used for executing methods. And unlike the heap, the stack operates in a last in, first out basis and does not use a garbage collector. It also stores references of new objects, which typically reside within the heap. So objects reside within the heap, but stack stores references which are used within any method. So we are going to break this stack further in the next slides. And then the heap. The heap is where all Java objects live. So if we come into the heap, we have instances of classes, which means objects. Instances of classes are objects. We have arrays, which are also objects. We have and then basically new objects, other types of objects. Then the GC manages this space. The garbage collector manages this space. So I tried to make a to put this picture to see how it can help us understand better pictorially what the stack and heap look like. So here in the on the left side we have the integer 32, and then we have the references to objects which reside in the heap. So the 32 we are seeing here is an integer. Stack stores primitive integers, but not the class type of integer, the object type of integer. So within the stack, you can find primitive data types, Boolean, bytes, shorts, ints, long, and the rest of them. But we're talking about objects. They primarily reside in the heap, and garbage collection happens within the heap. And garbage collection, if this was not stated earlier, means the deletion of objects which are not used in any running program within the lifespan of that program running. So if at any point I create a new object, or I do a new array list, or new any type of object, they are stored within the heap. And if at any point they are not referenced, it gets deleted for the sake of memory, so that the program can run smoothly. So by deleting it, you're freeing up space and you're preventing what they call memory leaks, which we're going to talk about in the next slide. So let me see if I can zoom this. I think it's yeah. So if I come to the next slide, we have what we call stack uh, and the heap. I'm just trying to help us to better understand what this actually means. So I have two classes here. One is the calculator, the other one is the demo class. So if I run a program and I run my main method, which is in the demo class, a couple of things happen. First of all, this value, the int values D and E are going to be stored within, first of all, a stack memory is being created. And these values, D, E, is going to be stored within the memory that has been reserved for this program now. And these are primitive integers. That's why you're able to store them here. And of course, you know that this D and E, they are basically variable references. And they are local variables, referencing the two integers. And then the next line of program comes to this guy, where we try to create a new object out of the calculator class. So what happens when this happens, when this is done? So this new object, first of all, we need to understand that this cow guy here is basically a reference to this object. So new calculator is the object we're talking about now. And this cow is basically a reference. So the new object calculator is stored, created and stored in the heap memory. And this guy here is basically going to be referencing it in the heap memory. And the new object has a number of instance variables in it when it's created. So we have the instance variable C is going to be stored in this object. We have the method is as well going to be stored as a property of the new object. So essentially, when um, when we get to this line and try to run the method called add, this is going to be added to the stack frame. This new method is going to be added to the stack frame. Of course, we recall that stack handles method operations. Any method that runs within a program, any new method that is running at any particular instance in time is going to be stored within the stack frame. So a memory is going to be created for this next guy here, which is going to run the add method, which is resided in this new object. And whatever value is going to be returned, we're going to store it. We're going to store it within our uh, main main uh, main stack frame, essentially. So I just want before I go ahead, I want to know if this is clear enough before I push ahead.
It is kind of confusing, but the way we are following, I think as we go down the line, we'll understand.
You can just let me know the part that is confusing. So which part is confusing
So
for you?
when you were explaining, I think the mouse were not pointing to where you were actually trying to explain. I think.
Okay, I'll just go over it again. I'll go
Okay,
over it again.
okay, thank you.
So when this program kicks off, of course, we are going to start our initialization by by with this main method running. We have primitive data D and E. They're going to be stored within the stack frame. I mentioned earlier that primitive data and references to objects are stored within the stack frame. Essentially, whenever you hear stack, just know that it's referencing to a method that is being run. That's that is method that is running, and then it stores the primitive data type that are created within it and references, just like this calc. References to objects. This is where the calc guy is actually created in the heap, and the reference is stored here. And then when we get to this line, the calc, which is the new object, runs a method within it. This is the method essentially. When it runs the method add, this add is belonging to the new object, Abi, but the method needs to run within the stack frame. And this is the add we are talking about. The method has to run within the stack frame, and then it creates if there's any local variable that is to be created within this add, it creates it. In this case, the local variable created for this guy is basically the one that is passed here, which is 1 and 2. So the local variable a here becomes 1. So there should be a 1 here, and B here becomes 2. There should be a 2 here. Essentially, this is the this is stack frame created for add. So whenever the program runs complete, and this add, whatever is done doing what it's supposed to do, which is 1 plus 2, a plus b, which is 1 plus 2, it returns, this guy here gets deleted, it gets removed, and then it returns the value of 3 and assigns it to this local variable f, which is what we're having here. So these guys get deleted. And when we are done running the entire program of this guy, we get our output, and this main is terminated. I believe it's better now. Okay, so coming to the next slide. Uh, so we have the last in, first out concept in Stack, as well as the Stack Overflow exception, the origin of Stack Overflow exception. So if you try to run a recursion or recursive method, you would you could experience Stack Overflow error if you do not create a break within the method. This slide essentially is to explain the last in first out, as well as Stack Overflow. So I'm going to demonstrate what I mean by that by this piece of code we are having here, this guy here. So essentially, when our program runs, we have this output here, which I outputted here, and then it calls this method, this calc, and passes a value of 1. This is the calc, and it passes a value of 1. So essentially, this guy gets added to the stack frame. A memory is created for this guy, which takes in the value of 1, which is what we have here for this first line here. Because you can see this thing is pointed out, entry method with number 1. So that's what we have on this line. So the next line runs, which is if number is less than 4. In this case, we know that 1 is less than 4. It runs what's within the block of code. In this case, calculates 1 plus 1. So this guy, a stack frame is created for this guy now. So it's not going to be, I tried to demonstrate it here as well. A stack frame is going to be created for this guy. So basically what I'm trying to explain here is recursion. And when we pass in 1 plus 1, essentially it will be 1 plus 1 is an expression which evaluates to 2. Essentially, 2 is going to be passed in here, and what gets printed out here will be this line, which is this guy here. When 2 is passed, which is this guy here. And then it gets to this line, and it checks if 2 is less than 4, yes. And then it's going to call this guy again, call itself again, doing 2 plus 1, 3, yes. So it repeats the process up until 4, which is this guy here, which is this last one here, 4. It comes and checks, is 4 less than 4? If that's true, it would enter here. But in this case, we know that 4 is not less than 4. So it's not going to enter here. It's going to jump here and write out this message, exiting method with number 4. That's how we got to this guy. So if you've been taking notes, you observe that we didn't execute this line for 1. You know, we started with 1 here. We didn't execute this line for 2. We didn't execute it for 3. We only executing it for 4 because we saw that 4 is actually not less than 4, and then we got here. That's to tell you that the last guy, which is 4, entered and is handling it first. That's what they mean by last in, first out. And it's going to handle the matters of 4. Whenever it's done, remember 3 is not done. Whenever 3 is done, it goes to 2. 2 goes to 1. So that's just the concept of the last in, first out. this class is not essentially for recursion. It's not something you understand in one class if you don't already understand. So, but the idea I'm trying to portray here is last in, first out. So the last guy, which is 4, he checks that 4 is not less than 4. That's why this guy finishes up executing. That's how we got to this guy. And then remember, it was 3. Remember, when we got to earlier on, when we got to 3, it checked that 3 is actually less than 4. That's how we got into here. But now we now have to finish up the program we are running, since we are done with this guy now. So it will print 3. It will print, when 3 is done, it will print 2. When 2 is done, it will print 1. And then after everything, this last guy is printed here. I don't know if it's clear. Does it make sense? Okay. It's just the same person that thumbing up. Okay, okay. So remember, we did mention that a memory is allocated for stack whenever a program starts running. And in a situation where there's no sufficient memory, what I mean by that is, imagine I ran this program and I said maybe if I ran this program and did maybe um I made this condition not to ever break, because we realized that it broke when 4 was less than 4. So when 4 came in and we saw that 4 is actually not less than 4, that was when this program broke. And then it started returning to 3, it returned to 2, and returned to 1 and finished up. Imagine there was a situation where this guy is not is not resolving to false, meaning that it is always resolving to true. Imagine I put if 2 is equal to 2. This is always going to be true. So this program is going to run recursively. It will do for 1, 2, 3, 4, just like that, 5, 6, up until there's no memory from stack which is able to handle whatever number, which is maybe 10 billion or whatever. The program continues running and gets up to that level. Because there's no memory sufficient in the stack again to run at that point. That's the concept of this stack overflow error or exception. So that's the origin of Stack Overflow, which I believe is named after a popular site, Stack Overflow, where other developers are able to make contributions for those who need help. Basically, overflow means you need uh, what am I explaining? So Stack Overflow essentially means where you can go and source whatever knowledge you are looking for. I don't know if the Stack Overflow thing I've explained, if it makes sense. If yes, I can go to the next one. So now we can you can talk about collection. So it's something which happens within the heap memory. We've spoken about stack, and then we're talking about heap now. And then garbage collection is something which happens within the heap memory. And then it says that it's an automated process that reclaims memory occupied by objects that are no longer in use. We already know that objects are stored in the heap. It is a critical component of Java's managed memory system, which frees developers from the burden of manual memory management. But also, it can introduce performance challenges. This we'll see later in this course as well. So, if you've written the C program, this subtopic is going to make a whole lot of sense to you, because in C, you manually have to delete the memory you've created. You manually have to create a memory and delete it. For now, you have this functionality in Java version machine, which is now doing the dirty work for you. That when you're done using an object, it checks and then deletes it from memory. So if you can, you can try to work with C and see how you manually have to create memory for some occasions and then delete it whenever you're done, so as to free up space for other operations within a program. So how does garbage collection work? In general principle, the garbage collection is to find objects that are reachable, that is still in use, and assume every other object unreachable to be due for garbage collection or deletion. The memory frame from these unreachable objects can then be reclaimed for other programs. And most garbage collection algorithms follow the three basic principle phases, which are marking. The collector identifies all objects that are still live or in use or reachable by the running application. It starts from a set of known GC routes, e.g., local variables, active threads, static variables, and recursively traverses the object graph to find all accessible objects. Basically, it's trying to identify objects which are no longer in use. And then the next phase is the garbage collector scans the heap and removes all the objects that were not marked as live during the marking phase. This frees up the memory space they occupy. And then the compacting. The To prevent memory fragmentation, the creation of basically fragmentation means the creation of many small scattered blocks of free memory. So to prevent that, some garbage collector algorithms move the surviving or live objects closer. This creates a larger contiguous block of free space, which makes future memory allocation more efficient. So basically bringing objects closer, which are still in use, closer in memory, and prevent its scattered appearance, sort of. And I have a pictorial representation just to help you understand what garbage collection is. What kind of objects can be removed when the JVM is running a deletion or garbage collection process. So we have class A, and this A, remember, is a reference to this guy, new my class. So this new my class is an object created, and then we have another object. The first one is called object one, and then we have the second one. The reference is B, and another object is created and stored in the heap, and it's called object two. Now, when I do A equals B, what I'm essentially doing is I'm pointing the reference of B into A. So whatever object A was pointing to, which originally was this guy, is now going to be pointing to what B is pointing to. So that's to say that A is pointing to this guy and B is pointing to this guy, and nothing is pointing to this first guy, object one. I'll just take it again. I have this first guy, I have this second guy. They are pointing to different objects, two different objects in memory. And then I come to this line. This is just a very simple process to explain what kind of objects delete during the process of garbage collection. So I now have this guy A, and I'm pointing to whatever object B is pointing to, which is this guy. So that's to say that B, nothing happened to B. I didn't change the reference to anywhere. It's still pointing to this guy. But A, I've now made it to be pointing to this new object. It then means that, and you can see that, whatever code I run afterwards with A is going to be referencing this guy here, no longer this first guy. So when JVM does this process of garbage collection, it's understand that this guy is no longer referenced or reached, and therefore uses it deletes this guy essentially, this first guy, this first object one. I don't know if it makes sense. Okay. So the next one. Uh, so how does GC decide when to run? Java's garbage collector monitors the heap continuously. It kicks in automatically when certain conditions are met. Say memory pressure. When the JVM detects that free memory is getting low, for example, you can just forget about this guy here. When it detects that memory is getting low, it runs the process of garbage collection. And then allocation failure. When there's no enough space to create a new object, it runs the process of garbage collection. The last one is explicit request. So you can actually run some methods to actually do it yourself. And some of the methods are this and this. So this one, you basically will not have to ever do it since JVM handles it for you. But if you want to test out how it happens, so Java has provided you these methods for you to play around with. So the next guy, memory leaks. So memory leaks essentially means when there's not enough memory for a program to run. And it happens when a program keeps references to objects that are no longer needed, preventing the garbage collector from removing them. So some scenarios with memory leaks are static collections, catching without eviction policy, and not closing streams or resources. So these 3 points are explained. So static collection, which is point one, it means static variables live for the entire, what it means is that static variables live for the entire lifespan of the application. So if you store data in a static collection and never clear it, those objects stay forever. Now the problem is that static static list, so it actually refers to this example here. So we have this guy called catch or cache. This guy is of type list. It keeps growing and never gets cleared. So this is just an example to show what static collections actually means and how it prevents garbage collection. So even after the main method, which is this guy, ends, garbage collection can't reclaim the memory because cache is still holding all references. So because this guy is static, you know what they say about instance when you create an object, you know what they say that static methods belong to the class, or static variables, they belong to the class itself. So if this static was not here, this class would not this method wouldn't be active. It should only be active when you create an instance of leak example class from out of this leak example class. So in a situation where you've made the methods static and made the variable static, it then means for long as this class exists, this new object I release is going to be alive and active because you've told it to belong to this class. So I don't even need to create an instance of leak example to be able to use any of these two guys, the catch and the main method, because I've declared them to be static. So no new instance is needed to be created. So in order to handle this, you can decide to make this guy. You can decide to remove. So static can actually be harmful. Essentially, that's what this guy is saying. So you can decide to make this thing non-static, or you can decide to clear this cache. You can decide to run this method dot clear. Of course, you know array list or list has different inbuilt method within them, which clear, dot clear is an example. Or you can just as well set it to null, meaning that it's not pointing to any object in memory. So because this guy is declared as static, for as long as the program is running, meaning that this leak example is going to be alive and active. Whenever this guy is done, this main method runs, it populates it with the number of times this for loop runs. It populates this catch list and for the number of times this loop runs. And that means that it's actually going to be consuming some memory for it to be able to hold this data you stored in it, data one, data two, up to data 100,000. So that's actually memory being used. And it's used essentially when this method runs, basically when the program runs. Because if they declare this guy to be static, if it were the case that this guy was not static, it means that I can decide to run this method when I've created an instance or object out of this list class. And in that case, that object can be deleted when garbage collector sees that it's not referenced anywhere in the program. But if it insists that I want to leave it as static, then I might as well do justice by using this dot clear or setting it to be null instead of it still holding data which are not used within the program. Does it make sense? Okay. So the next one is catching without eviction policy. So we are used to using hash map, and it's possible that we may want to put in a new object within this catch hash map. Say we call it user one. Essentially, this guy is a reference. This keep side is a reference to this new object. That's how hash map works. So anytime I call user one, it basically returns this object for me. So, and you know this new object is stored in the heap, and we are talking about memory allocation or avoiding memory leaks. So essentially, whenever I put this guy here, this user one, this new object, whenever I push it in this guy, it stores within this cache. So it's possible that within my program, I would use user one in one occasion. And after the occasion, I wouldn't need to call user one again. And you know this cache can hold many other key values. Maybe user two pointing to something else, user three, you understand, many different things. It's possible that this user one is only has been called and it has done its purpose. Now we need a way to be able to delete this guy since it has done its purpose. It's going to be existing because this catch is still existing. It's not only user one that is containing, it has user two, user three, and every other key, which are pointing to different objects. And you know that this guy is on the value side is only object that is stored. And all of these objects are pointing into the heap memory. So in a situation where this user one has been called, we need a way to delete it. So with the use of weak hash map, it deletes this user one, having seen that it is not referenced anywhere within the program again. So catch is an object, it's still going to be existing. It's there to answer to any other time we want to call another key, maybe user two or user three, like I mentioned. But this guy has been used, user one, we don't need it again. So with the use of this weak hash map, it's able to delete this user one or remove it from the hash map on. So all of this can happen underlining. When it sees that it's no longer being refreshed, it removes it. Alternatively, if you've seen that you use user one, you yourself, and you know you're not going to use user one along the line in your program, you might as well just do remove it from your hash map. But if you're lazy and you don't want to do that, you can just use the weak hash map. So that's what this guy does for us. So I hope this is clear. So the next one is not closing streams or resources. So this is something that can easily occur when we are reading files from our systems. So when you're reading files from the system, we use something like file input stream, and then you create the reference, and then you create the new file, depending on where the file is residing in your system, whether it's home slash wherever the file is residing. So this new object is created, and then it's opening a connection to this directory within your system. So two things are happening here. A new instance is created in the heap, this guy, and then you're opening a connection. Your system, your operating system is opening a connection for this file to be read. I believe that's what this to So this guy says heap memory. Uh, sorry. When you open a file or connection, Java allocates heap memory because this file needs to be created in the heap, and then native resources outside the JVM. What this one means is that a connection is opened by your operating system so that this guy is able to read whatever file you're referencing. Now, if you do not close these resources, if you do not close these resources, the Java object stays reachable, or at least the native handle does. So the Java object stays reachable. What this guy means is that in the situation where garbage collection doesn't happen for this object, so it stays reachable because it's still referencing to this guy, or it says, or at least the native handle does. So connection is different from the object, or at least the connection, that's the connection opened by your operating system, still remains open. So and then it says the underlying OS resource remains occupied because it's open. And garbage collection can't reclaim native resources. It only frees heap memory. So it's garbage collection essentially frees heap memory, we know, but then it cannot reclaim when it cannot reclaim native resource. When eventually this object is being deleted, is not able then to reclaim the resource we're trying to reach, because the object needs to be alive first before you can be able to claim it. So in the situation where, oh man, sorry. So in the situation where the connection remains open. Now I'm not talking about whether the garbage collection has happened or not, but in a situation where the operating system leaves the connection still open, that is a memory that is being used. And now imagine you do that in many instances within your code. You could get to the point where you experience this error here, Java IO exception, too many open files. So memory is being used for each time a file is being opened within your operating system. And then Java, when there's no memory sufficient for you to open another file, Java throws this exception that you have too many open files. So you then need to close the files that you have opened previously. So typical example to demonstrate scenario where someone opens files and never closes them is when we call this guy, then there's no line to close it. And this file is being opened for 1,000 occasions. Perhaps you've now reached the limit where the operating system is not able to allocate more resources. So in order to prevent that, you use the .close method, which is within the file input stream. Alternatively, you can use the try with resource because this is something new. With it came in, I believe, in Java 7 or 8. So it alleviates us of having to use this method explicitly by ourselves. So with the use of try with resource, it closes it automatically. We do not have to handle that ourselves anymore. And this is a typical example where try with resource is being used. So okay, this is where I am. So this is a typical example of a use case of try with resource, where you define um, the class, and then the ob you essentially you're instantiating an object. But by you inserting it into this try, if you recall this try, yes, okay, try is not even used there at all. But if you use try, you would know that you just do try and then you open the curly braces. But here you do try and then you have this parenthesis where you insert, where you create your object before you even use the curly braces you're saying here. So automatically this guy implicitly runs dot close methods for you, where you don't have to close the connection to the operating system or to the file in your operating system. So I think this is the last of the slides. So if you have any question, you can go ahead and ask.
Hi, thank you, Mr. Somtochukwu. Uh, well, thank you for that powerful section. Yeah. So please, if you have questions, please do raise your hand. Yeah.
Please go ahead, Samuel.
Okay. Thank you very much, Mr. Cynthia. So, like, uh, I mean, so far, my from my own personal experience, I've written my code. I've not like paid like attention to this garbage collection. Why the knowledge might be there, but like in like enterprise level of application, like you work at UBA, so I believe you handle like those like core banks application. So where does it actually comes into play? Like where does the knowledge actually, is it something I would have to be like careful when I'm writing a particular code, or just I don't know where does this particular memory management concept, because I believe the garbage collection, like it happens on the background, like it does its thing without me interfering. So is it something I need to be like cognizant about when building probably enterprise level app application?
Okay. Yeah, thank you for asking. So the answer to the question is yes, it's something that you have to be intentional about. Um, so the reason for that is that uh, obviously when you're dealing with an organization that handles multiple, like large customer base, you have to be careful as to know um, that that, for example, I'm just trying to make reference to what I've just talked about. If, for example, you let me just make use of this try with resource, or rather file handling, that I talked about. If you have a program, because we do make references to the files in the operating system. So if you have a program, I'm just trying to demo one scenario where it comes in. If you have a program where you're trying to handle all customers' requests, and you run the program, and then maybe references to the operating system and fetches a file in the system and does whatever it needs to do, and then he fails to close it. And remember, when you deploy something to production, it's live essentially. So what that means is that if you've opened that file, it's going to be open for that particular customer you're treating their request. And then the second customer comes. Remember, that open guy is consuming space. And then the second customer comes, and then you go to the system and pick up their details, and then you treat their request, and then you fail to close it. That's another memory that is being consumed. So when you're doing this thing on a smaller scale, maybe on your personal level, or when you're treating customer requests that are maybe in hundreds, few, it might not be an issue. It may not be an issue, but the issue comes in when you have to handle a large customer base, and then you now have to start understanding the importance of closing resources whenever you open it, or importance of following practices that allow garbage collection to delete objects that are no longer in use. So it's just something you have to put in your blind spots. You don't even need to think about it. You just know that you're handling too many requests, and just have to try to use the best practice. It may be the case that it's not always going to be that you're not always going to use the best practice, but just have it at the back of your mind so that when the issue arises, then you can think, oh, maybe I didn't do this thing, and then the solution comes to you. I
Thank
don't
you
know if
very
it makes
much.
sense.
Thank you very much.
Right, please go ahead.
Yeah, thank you, Mr. Somtochukwu. So, my question is, at the beginning you mentioned that Java is a write once and run everywhere, right? Yeah. So the question now is that, every operating system, has its own way of, interpreting its machine code, right? Meaning that, okay, the machine code of Windows can be, different from the one of Mac, right? Good. So how then does, JVM come in and make Java, a platform independent? Like, how does it actually solve this key problem? Yeah, I think that's my question.
Oh, okay. So you can think of it that JVM has now been designed to handle um, for all of the operating systems, regardless of whichever one it is, Mac, Linux, or Windows. So if you're able to get, um, can I say, a good JVM that is able to run programs designed for each of these guys, whether it's Mac or any other operating system, it basically does the job. So when you're installing Java for, I think these days you don't even have it in mind that I'm installing Java for Windows, and it actually may not be able to run codes that have been designed or that have been built by my Mac OS. So the reason for that is that those who ship out uh, Java, the latest versions of Java, JVMs, they do that keeping in mind that people need to be able to move their codes across operating systems regardless of whichever whichever platform they want to run it on. So the designers essentially, and what I'm talking about, they've kept it in their mind that JVM needs to be platform independent whenever we are running the byte code. So essentially, when you finish writing your Java code, those classes that end in .java and the rest of them, it gets compiled into the .jar file. So we have been we have been blinded such that we don't we don't make use of those libraries manually. So there are some tools that you'll be using. Just I did mention earlier about the ESB by IBM. So that guy doesn't make use of Maven. Maven at the back end just finds the one that is compactable and compactable of whatever program you're running. It just finds the one and installs it for you at the background. So essentially what I'm saying is the JVM compiles it into that .jar file, and then you're able to move it around. So the designers of JVM Java, they build it regardless of whatever platform it is you want to run it. I don't know if it answers the question.
Okay, thank you very much. So that means that, the ability of Java to actually be platform independent lies on you being able to install the JVM specific to your own operating system. Then JVM now breaches that gap using the bytecode, jar file, will I say bridge, right?
That's correct, yeah.
Can you hear me? Hello?
Yes, yes. Yeah, I responded. Can you hear me? Bryce, I can hear you. I said that's correct. I responded.
Okay. Hello? Hello, Bright.
Okay, thank can you hear me? Hello, can you hear me? Yeah.
Yeah, okay.
Okay, thank you. Thank you.
Okay. So, Mr. Bright, you can continue.
Okay, thank you. Thank you, for that. Is there still more questions? Is there questions? And I believe we'll still have a little bit of time for more questions. Please ask. So if you have any questions, please. So we have, yeah, we have Aderonjo. Please, can you go ahead?
Uh, Good evening, everyone. Please kindly confirm you can hear me.
Okay, hey.
Yes, the name is Adiroju Israel. So mine is more of should I say, a contribution. So because thank the presenter, you understand, for the highest opening presentation so far. So I would have also like the presenter to mention how this affects us, uh, when it comes to actually making use of both garbage collection and memory management in, the real life. You understand? So I mean, how these affect us, the applications of this, how they actually affect us. To actually make sure that every developer out there starts being intentional about garbage collection, memory management. I mean, these are things that affect your memory usage in terms of probably where you're hosting your services, the performance, response time, how you even scale or how reliable your services are. So I would have loved that, from the perspective of the presenter. I mean, where it's coming from. So he would have been able to share that with us. I mean, just uh, real life experience or real life scenarios of how that's maybe costed them some sort of money in terms of hosting. I mean, you know, that's I was just expecting that we have that. I mean, from the whole, say, should we say, banking experience or fintech experience. So I don't know if it could maybe just give us some sort of real life scenarios around that. So thank you.
Okay, thank you, Mr. Israel, for your question. So, a typical scenario where this would affect you or your service is the reliability of your service. For example, there are instances where you open a site. I am not saying this is a cause, and then it takes too long to open. I'm not saying this is a cause, but I'm trying to point out at the TAT, that's the turnaround time. What this means is that when you send a request, how long does it take for you to get your response? There are sometimes when you open a site and then it takes forever to load. That's because something probably is not going right. So as a backender, there are sometimes when the customer tries to finish a process, maybe a payments process, in a situation where you may need to generate invoice for them and it requires you to open a file to customize the invoice and send to their email. And then you have many files that have been opened. I'm still using an example of the opening a file without closing. I'm still using that instance. And then you fail to close it. At the start of the program, when you've gone live, everything could be fine, no issues. But how is it going to be in 12 months to come? Is it still going to be fast? And if not, what could be a possible cause of it? So this is the situation where you need to be intentional and how it can affect your service. It's not even about the financial cost here, but the performance is actually more dangerous that your service is not performing well than you have to incur more cost financially because you lose your customers. But in a situation where you still have your customers, you can still recover your cost. You can still grow more customer base. So it's not even about the financial cost we're talking about here, but your service, how is it behaving? How is it performing? And then the question of how we can reach more developers comes in by from this particular session because I've actually had some presentations. Um, so for I mean in a different event. So for events like this and like that of the one I'm referring, so it brings more awareness to more developers of what they might be missing out on how to improve their service or something they are doing wrong, basically. So for the first one, it's more important to have a service that is running fine. Not talking about the financial aspect of it now, but let it be reliable. I don't know if this answers your question. Mr.
Yes, I would say some parts, you understand, but
Okay,
my
which
my my thought actually, or the thought process around what I said was to act is actually aiming for your own experience. You understand how you've been able to resolve this. You understand when it comes to you would have probably younger developers amidst you that maybe while you are merging their code or something was skipped. Understand, or probably you feel like okay, yes, your guys are they done their due parts. Okay, let me just go ahead and make this, and this, sort of disturbed some sort of thing when it comes to your service. I mean, for the context we are talking about now, which is the memory management and garbage collection. You understand? I mean, just the life scenario, except maybe there's none. You have not experienced any. I mean, in the practical world. So that's what I'm aiming for, actually. You understand? Like what you yourself have experienced now, in the banking sector, when it comes to memory management and garbage collection. How was it resolved? How was it handled?
Okay, so in a practical experience, I wouldn't say that I have experienced it. However, I have seen a scenario where someone has experienced this kind of issue, and his own situation was such that they were trying to do a hot, um, can I call it hot memory? So what that means is that they are trying to prevent a situation where they have to be going to the database to be fetching records every time, every time. So for example, someone wants to make a transfer and they put in the person's account number. They don't want to go to database to fetch the person's first name, person's name and other details. So what that guy did was basically to have a hash map which stores the information in the hash map. In that case, it's actually doing the job. It doesn't go to database to retrieve whatever information it's looking for, which is fine at start. But then as the program continues to run, as time continues to go, as more customers continue to onboard, remember, you're still going to that hash map, which stores information for over months without deletion. It keeps growing. It keeps increasing information that is stored within it. This is not my experience, but experience of someone who has mentioned to me. So what that essentially did is when they log on to the terminal of the program of their operating system and you do df minus h. So what that essentially does for you on Linux is that it shows you the memory that is being consumed within a particular disk. So essentially, when the guy checked within that disk and realized that memory continues to grow, it wasn't clear what the cause is until they drilled down and figured out that it was the hash map, which is returning information, which continues to grow. Because you can't delete files, you can't delete everything you know that is deletable. But it's trickier to find out that is even something living within your program that is building up um, that memory. It's trickier because you know that you need to delete your error logs, you need to delete your standard out because every system has a standard output or standard error. You've deleted those ones, your log information, but then memory is still being consumed. And how is that so? And then the reason is because someone is trying to do a hot memory, how do I put it, where they don't have to run to the database because yes, it does save you time. It's more expensive to go to database and retrieve information compared to someone who study a hash map. Because with database, you need to create your connection first. You need to run the query before coming back to the program. But with hash map, you just stay within the twinkle of an eye. But that's at the expense of product's performance. Don't know if this helps you to understand better.
Yes, sir. That's fine. So I guess we just move ahead. So because the time is fast spent, so that every other person could make their contribution or ask their question. Thank you.
You're welcome. Seven.
Okay, yeah, I think based off of what you just answered, I think that's. Can you hear me?
Yeah, clearly.
Okay, okay. So I think based off what you just it's answered what I was actually about to ask. So I think that's in line with what I want to ask. So, thank you very much. Mr. Bright, you can continue.
Hi, thank you so Somtochukwu, yeah, for the answers. Yeah, so I don't know, is there any more questions? Is there any more questions? All right, there's none. Yeah. So thank you, Mr. Somtochukwu, for that powerful, insightful section on memory management and garbage collection. So I'm sure that we have all picked valuable knowledge that we can, apply in our Java development journey. I personally have grabbed a whole lot, honestly. The platform independence, yeah, the closing of file and using the try catch and the try with the resources here. So it's a whole lot for me. Yeah. So to everyone who joined us today, thank you for being part of this session. And if you have enjoyed this and you would love to connect with other Java developers, stay updated with future events, job opportunities, technical discussions like this. Yeah, so we'd love to, have you as part of our NaijaJUG developer group. Yeah, yeah. So NaijaJUG developer group. Yeah. So I've dropped the link to our social media, channels on the comment section. Yeah, so you can just click and join, right? Yeah, so that is it for now, and thank you very much. So until next time, take care. Bye.
Hello? Okay.
Yeah, Mr. Suntochukwu. Yeah.
I just wanted to drop the link to the slide. That's all. I've dropped it.
Thank you very much. Thank you.
Okay.
Yeah. All right.
All right.
Thanks. Bye.
Yeah.